Well, welcome back to the Frost River Subdivision. I'm Mark Underwood, and this is episode 8 of my ongoing layout update series. Today we're going to take a look at the main power supply for the layout, and I've used a somewhat unusual approach. I won't call it novel, and it's certainly not my invention. But I found it being used at other places and thought it was a very good idea, so I did my own little spin on it, and so let's take a look. What I've chosen to do for powering my layout is to use a computer power supply. This is a 400 watt ATX style power supply. It's made to go into a ATX style PC computer. It's nice and compact. I think I paid about $30 for this thing. You can probably salvage one out of one of your old computers. You have to do a little bit of work in order to make this functional though, and that's where this part here comes in, and I'll be talking about that in just a minute. A couple of reasons that these are really useful. They're commercially made, they're cheap, they're very high power. This thing will deliver something like, check my cheat sheet here, 20 amps of current at 3.3 volts, which is great for lighting, 14 amps at 5 volts, which is also very good for lighting accessories and things, either 13 or 14 amps at 12 volts, which is what I'm using to power my Digitrax system. It's also got a lot of power there. It's also got some nice features that allow you to shut down the output while keeping it plugged in, and it's got overcurrent protection, thermal protection, all of that stuff built into it. So it makes it a very useful power supply. So there's a couple of, you can see this whole mass of cables that come out of the output of this. Well, let's talk about the input first. The input's the easy part, right? You've got your industry standard computer power supply cable connector and a master power switch. And also, if you happen to be overseas, this has a 115 220 volt switch, so you can use this anywhere. Okay, so you get this mass of cables coming out of the output. There's a couple different kinds. You have these cables here, which are the old style connectors for hard disks, CD-ROM drives, that kind of thing. There's also the newer SATA style connectors, and a couple of these smaller connectors that were used for like 3.5-inch floppy disks, which had the same connections as the big old ones, just in a smaller connector. There's also this one here, which provides, I think, auxiliary 12 volts for the computer motherboard. And then you have this guy, this big massive cable here. This is a 24-pin connector on this cable, and this is what normally supplies power to the motherboard. Now, these power supplies expect to have a load on them, and they also expect to have some signals coming back from the motherboard to tell them that everything is okay and that they should be powered on and putting their output out. And that's part of the protection, because these things will put out a lot of current. You can easily cause some serious problems if these things aren't controlled. So what I did, I built this little circuit board here. I wonder how close I can get and still be in focus. So it's got the mating connector for this big 24-pin cable. It has this big 10-watt resistor here, which just puts a load on the power supply, so it thinks there's a computer out there drawing power all the time. If it doesn't see a load like that, it's not going to be able to regulate well, and it's going to shut itself down automatically, and you won't be able to keep it running. So that just kind of puts a little artificial load on there to keep things running. I've got a switch which turns on the outputs, and so when I flip the switch on, the power supply thinks everything's okay, it turns on the outputs. If I throw the switch down, it shuts everything off. Also got these 3 Anderson power pole connectors up here, and these tie into the motherboard cables, 3 volt, 5 volt, and 12 volt outputs, so that can connect accessories up easily. And these 2 LEDs, The first one tells me whether this switch has been flipped, and so I know whether the line power coming from the wall is on. And this LED lights up when I turn this switch on and enable the output to the layout. So I've got media feedback. These are pretty bright LEDs too. I think I should probably put a bigger current resistor on them and make them a little bit dimmer. They're very, very bright underneath the layout. That's not necessarily a bad thing. So this is a pretty simple circuit. I mean, you just got a couple of LEDs connected to, this is actually connected to the 5-volt power rail, so I can see that the 5 volts is turned on, which means everything else is too. And you know, the other LED is just connected to the main power. One thing, I don't know if you can see this very well, but the circuit board has, I mounted it using these little standoffs, just screwed directly into the metal of the case of the power supply. But if you can see under there, the pins, the bottoms of the pins of the connectors and the LEDs and everything kind of stick down below the edge of this, or the bottom surface of this circuit board. And it's possible, because there's no mounting screws on the bottom, I guess I could have put some there, that this can be pushed down and could potentially make contact with the metal here, which is grounded, and that would cause a short circuit, and you know, it's going to fry things. It's going to cause problems. Most likely the power supply would just shut itself down and everything would be fine. But just to make sure everything was okay, I took a piece of styrene. This is like 0.80 styrene. It doesn't really matter what thickness. I just kind of glued that in place to protect and make sure that none of those little pins sticking down there are going to make contact with the power supply. So how am I using this? Right now I have, I'm using the 12 volt power to power some of my detection equipment. I have a Digitrax BDL 168 current detector, which requires its own 12 volt power supply. So I'm tapping off of the 12 volts here with an accessory power cable for that. And then right here, I cobbled together a connector and a cable, which I'm hoping to redo a little nicer. And the other end of this has the appropriate connector for my Digitrax Zephyr Extra DCS 51 command station. So this connects to the 12 volts from the power supply and allows me to power my Digitrax Zephyr using this. So when I got this thing plugged in, powering up the layout is as easy as flipping that switch. Everything comes on, and I can turn on the track power on the Zephyr, and you know, I'm good to go. Time to shut down and go home. I flip that off, I'm done. If I want to be really protected, maybe I'm going away for the weekend or vacation or whatever, I can always hit the master power switch over here, and the whole power supply is shut down. So basically, you know, I'm going to run the 5 volt circuit around and do lighting and accessory power with 5 volts, 12 volt for the things that need that much voltage. But most of the non-track power stuff on the layout is going to be on 5 volts because there's just no need to run that much power around. So this is, you know, this is my power supply for the layout, and wasn't very hard to build. There's a commercial version of this board that is available, and I will provide the URL in the video credits. It's nice. It's in a little box, and it has this connector, and you just plug into it, and it's got the switch and the LEDs and everything. I wanted to make my own because I like to make my own electronics. But if you're interested in doing this and you don't feel like cobbling together your own interface board there, you can pick up that commercial version, and I'll share that with you. Well, I guess that's about enough for episode 8. Kind of focused on one topic this time. Next up, I think it'll be about time for a tour of the layout and get some status, and maybe talk a little bit about the operation scheme. I've been doing some testing and trying to put that together so that it works well. So I think next time in episode 9 we will take a look at that. Until then, bye-bye.